Okay. Discrete probability. In year 12, we will learn continuous probability. Does anyone remember the difference between discrete and continuous? Continuous, any number that is not whole. So this discrete is a whole integer only. So for example, if I was to say like how many cars are on the street or how many dogs do you have or whatever the idea is, you'll give me numbers in whole integers. This can be 4.2, 3.8 and so on. So this will be in year 12. We'll look at continuous probability distributions and functions, whereas in year 11 we're looking at discrete only. So just so you know, it will be revised next year. We're going to look at frequency, a little bit of the language of probability, and then pretty much the biggest components here, which is finding mean, expected value, variance, and standard deviation. All right. Most of the basic stuff I'm not really going to cover. I'm sure once you guys get the booklet, it'll just make a lot of sense to you. I'm not going to do that either. All right, so probability distributions. The probability that a random variable x takes on the value xi is pi. So the idea is, it looks very fancy, right? But it's just the probability that capital X, a random variable x, that will always be a capital X, is equal to little x, is equal to some sort of probability, like something. We don't know. Like let's say p of x. It could be p, and where probability of x is equal to like 30% or 40%. So it looks really weird, but you'll get used to this bit here, writing this bit. Probability capital X equals little x. The collection of values and probabilities together is referred to the probability distribution. Yep. The probabilities must always be non-negative. I think we know that. And the sum of all probabilities must be equal to 1. Again, something we know. All right. This is how your probability distribution tables will look like. 4 coins are thrown. So you got to first think about 4 coins, right? 1, 2, 3, 4. And the number of heads is recorded. The number of heads is denoted by that capital X. So you could have X being, you could have 0 heads, you could have 1 head, you could have 2 heads, you could have 3 heads, or you could have 4 heads, right? Complete the probability distribution table. So it's always going to look like this. Your X depends on what it's asking you. So in this case, it says number of heads, so that'll be 0, 1, 2, 3, 4. You could have said number of tails, it'll still be 0, 1, 2, 3, 4. For a dice, let's say it could be 1, 2, 3, 4, 5, 6. Okay, so like it's like your outcomes, and this is the probability of that occurring. The probability of getting 0 heads. So what's the probability of getting 0 heads? Well, that means getting all tails, right? Heads, 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 tails, heads, heads, tails, heads, and so on and so on. I don't think I need to do this, but if you were to do this 16 times, the only time you're going to see no heads is the last one, which will be tail, 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 tail. So that's 1 out of 16. Or half times half times half times half. You need to work that out. So does that make sense firstly? Because generally this table is worth about 3 or 4 marks. Does that make sense? Yes. So okay, 1 head. How would you get 1 head? Well, you guys can see that's got 4 heads, that's got 3 heads, that's got 3 heads, that's got 2 heads. If I did another one, I did H, T, H, H, that's still got 3 heads, H, T, H, T, that's still got 2 heads, and then if I did another one, H, T, 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 there you go, 1 head, and that would happen 4 times. So 4 out of 16, and then if you list all of them out, you'll see 2 heads 6 times, you'll see 3 heads 4 times, and you'll see 4 heads just the 1 time, 1 out of 16. I'll pause there. Is anyone confused? Okay. The next thing you need to know, 2 things, 2 conditions just before we start. 2 conditions. These probabilities must add up to what? The probabilities of all of these, right? That's a capital X and that's a little x. The condition, the probability of all of these must equal to 1. The sum of all your probabilities must equal to 1. So that plus that plus that plus that plus that will equal to 1. You guys can test it. And that's the first condition. And the second condition is each probability must be between 0 and 1. Each probability must be between 0 and 1. Okay? Which just, it makes sense to you guys, I hope. It either can occur or can't occur. You can't be over than that. All right. If we don't have any questions, then these questions are not too hard. Find probability of x equal to 3. Well, what's the probability of getting 3 heads? 3 heads, 4 out of 16. What's the probability of getting more than 2 heads? Well, more than 2 heads means 3 heads or 4 heads. So 4 out of 16 and 1 out of 16, which is 5 out of 16. What's the probability of getting an odd number of heads, which is 1 or 3? So 1 head or 3 heads. So 4 out of 16 and 4 out of 16, which becomes 8 out of 16. Any questions? No? Okay. Let's look at another one. The number of pets X owned by each student in a large school is a random variable with the following discrete probability distribution. So number of pets owned, right? That's what you want. That's how you got to think about it. So that's the way we read this table is 0 pets owned, 1 pet owned, 2 pets owned, 3 pets owned, and these are the probabilities of that occurring. So the probability that there was 0 pets owned is 0.5, 1 pet owned 0.25, 2 pets owned 0.2, 3 pets owned 0.05. If 2 students are selected at random, the probability that they own the same number of pets is, there's 2 of them, the same number of pets. That means they can both have 0 pets, or 1 pet, or 2 pets, or 3 pets. So that's 0 pets, so 0.5 times 0.5 plus, or the first guy could have had 1 pet, and the second guy had to have 1 pet as well. Or it could have been 2 pets and 2 pets, or it could have been 3 pets and 3 pets. And that becomes C. Any questions at this stage? Okay, let's do the next one. So this one says show that this p of x, this polynomial or this function, where x is 1, 2, and 3, and 4, is actually a valid probability distribution function. Well, we know there was two conditions. We know that as we find the sum of these probabilities, they must equal to 1, and then each probability must be at least between 0 and 1. So let's have a look. When we sub in 1 into here, you get 2 out of 34. When you sub in 2 into here, you get 5 out of 34. Sub in 3, sub in 4. So there's your probabilities of each event occurring. All of these obey, the probability being between 0 and 1. And when you sum these up, it actually does equal to 1, which means it's a valid probability distribution function. So this is just a function, and it's saying like anything could be a function, right? You could have said p of x is equal to x squared. But that one doesn't make sense because when it's at 1, you already have 1. But when it's at 2, you're going to get 2 squared, which is 4. So it fails the fact that it has to be between 0 and 1, and it fails because 1 plus 4 is already 5, and that can't add up to 1. So let's say this case, this would never be a probability distribution function. Because it just won't work. For 1, 2, 3, 4. It could be for smaller numbers, but it won't be for 1, 2, 3, 4. Okay. Uniform probability. A probability distribution is called uniform if all of its values have the same probability, i.e. the values are equally likely. So a die is thrown, write out the probability distribution for the number shown on the die, and then graph the distribution. So obviously you guys know in a die, 1, 2, 3, 4, 5, 6, the probability of that occurring is 1 over 6, 1 over 6, 1 over 6, 1 over 6. And then graph it, 1, 1 over 6, 2, 1 over 6, 3, 1 over 6. And it's just going to be these 6 dots. Nothing too fancy there. It's uniform. For those who understand uniform, it's not changing, it's just constant. Expected value. Something you do need to know. All right. The expected value. Expected value is another way of saying mean. You guys probably have been used to mean being average. It's not true. Average and mean are two different things. And now as you're getting older, you start to learn that. So the average is the way you know average, which is, add up everything and divide it by 2. The mean is what we say has some weight to it. And you'll understand weighting, I think, more in year 12. But mean has weight or expected value. It describes where the distribution is centered around. Variance describes how something is spread out, how far it moves away from the mean. Standard deviation is just the square root of variance. Any questions? Okay, so the expected value, E of x, is the mean of the theoretical distribution and is the sum of the product of each outcome with its associated probability. Again, sounds fancy, but I'll make it very simple for you guys. So the expected value of x, is also represented by the letter mu, mu, that's how we say this, mu. And it is the sum of your x's, x multiplied by the probability of your x. So that means if I think about, let's say, the dice question that we just saw above, 1, 2, 3, 4, 5, 6, The probability of each one occurring is 1/6, 1/6, 1/6. The expected value of this, or the mean of this, is 1, right? The sum of the x's multiplied by the probabilities. So 1 times 1 on 6 plus 2. 2 times 1 on 6 plus 3 times 1 on 6 plus 4 times 1 on 6 plus 5 times 1 on 6 plus 6 times 1 on 6. Okay, any questions at this stage? So it's pretty straightforward. I don't think it's too complicated. It is new, I guess, for you guys, but there's nothing too hard about the concept of just multiplying this by this. As long as you keep in mind that's how you work out your expected value, just multiplying. All right, and then that should give you, I think it gives you like 3.5 or something from memory, which is pretty interesting itself. But anyways, there it is. So consider the experiment we just did above, the toss 4 coins one. There are the there is the probabilities that we worked out above, and then it just says find the expected value. The expected value would be 0 times 1/16, 1 times 4/16, 2 times, 3 times, 4 times, add it all up, you get your expected value being at 2. Probably the easiest 2 marks you're gonna see in your exam. Okay, any questions? No, pretty easy. All right, let's have a read of this. 20 friends go out to dinner at a Vietnamese restaurant. One has $560 cash. 4 have $350 cash. 2 have $180 cash. 3 have $80 cash. 4 have $50 cash, and 1 has $40 cash. 5 have no cash, and I expect him to borrow from the others. An armed robber bursts in and seizes one of the friends at random. She threatens him, grabs all his cash, and runs away. Construct a probability distribution table and find her expected criminal gain. So there's your x. There's your probability of x, capital X being little x. All right, how much do you expect to gain? So obviously she could have got $0 from 5 out of the 20 people. She could have got $40, 1 out of 20 people. She could have got $50, 4 out of 20, $80, 3 out of 20, 180, 2 out of 20, 350, 4 out of 20, 560, 1 out of 20. That all makes sense, I'm sure. And then to find the expected value, you're just going to do 0 times 5, 40 times 1, 50 times 4, and so on and so on and so on. Multiply and add up all the probabilities. It should add up, answer should add up to $140. Pretty straightforward. Right? Any questions? Has anyone done this at school yet?
Yeah, I have.
Oh, yeah?
Yeah.
And so this is easy now, second time round? Yeah.
Yeah, it is easy.
Cool. All right. Oh, there it is. So a regular 6-sided die, graph the distribution. We graphed it above. Find its expected value. So this times this plus this times this. We just did it. It does give you 3.5. That's nothing. All right. Here's another one. The discrete random variable x has the following probability distribution. So 0, 1, 2, 3, and 6. And there's the probabilities of each of occurring. Let the expected value be the mean of the x. So let mu be the mean of x. Find the probability that x is less than mu. Well, first thing you've got to do is work out what that mean is, right? So to work that out, it is 0 times a quarter plus 1 times 920, 2 times, all right, I think we get that. You get the mu. So you're trying to work out the probability that x is less than 17 on 10. 17 on 10 is 1.7. So for it to be less than 1.7, that means 0 and 1. So a quarter and 9 out of 20. Which gives you, looks like the answer is 14 over 20, which is E. So we get that. So if I could have said, what's the probability that x is greater than mu? You would have said, okay, that means probability of x greater than 1.7. Being greater than 1.7 meaning 2, 3, and 6. So that's the probability of 2 plus probability of 3 plus probability of 6. And then probability of 2 is 1/10, 1/10, 120, so 110, 120, 320. So 1 on 10, 1 on 20, 3 on 20. Any questions there? Or does that make sense? This one's going to be a hard one. That will be our last question for today. And that's going to be a really hard one to wrap your head around. This one's a really easy one. Consider the following discrete probability distribution for the random variable x. The mean of this distribution is, saying to find the mean. What's the problem before I can find the mean? What don't I have, obviously? I don't have P, right? What's the way of me finding P?
Making it equal to 1?
Yeah, making these 5 equal to 1. Yeah? So P plus 2P plus 3P plus 4P plus 5P, you know, must equal to 1. That's something you know. So P equals to 1 on 15. Once you know what P is, then you just go and do your expected value, which is this times 1 on 15, 2, 1 on 15, 2 on 15, 3, and 3 on 15, 4, 4 on 15, 5, and 5 on 15, and it should give you 11 over 3. Really basic stuff. So the harder bit of that was the fact that you needed to work out what the probability is, but that's obviously one of the rules or one of the conditions. The sum of the probabilities must equal to 1. So just add them up and solve for P. Very simple. Any questions about that one? All right, brilliant. That's going to be conditional. Yeah. Okay. We can do. We'll have to do this after next week as well, because it's conditional probability, which is what we're going to look at next week. So we'll come back to that one. That's 2 questions. All right, we should be able to do this. The probability distribution of a discrete random variable x is given by this table below. There it is. It just says show that P equals this or P equals this. Again, Rad, what are you going to do?
Make it equal to 1 again.
So you're just going to write 0.2 plus 0.6 P squared plus 0.1 plus 1 minus P plus 0.1 equals 1. Go ahead, you guys. I can see it's going to become a quadratic. So make sure you bring everything to one side, use your quadratic formula, or factorize, whatever you want to do. Go and confirm you do get these 2 solutions. I'll just give you guys 2 or 3 minutes. You could have just used the quadratic formula from here. So if you guys didn't want to multiply by 10, you didn't have to. All right. Anyone not able to get it out? No, we're all good. Okay. Let P equals to 2/3. Calculate the expected value of X. If P is 2/3, you're just going to obviously replace your P's here for 2/3. To find the expected value, which is going to be 0 times this, 1 times this, 2 times this, add it all up, you're done. Find the probability that X is bigger than your expected value, or whatever it is. I think we can cheat here. It says 28 on 15. 28 on 15 is 1.8. For it to be bigger than 1.8, that means it's the same as 2, 3, and 4. And then 1 over 10, 1 over 3, 1 over 10. Just add up the probabilities. 1 over 10, 1 over 10. This one looks like it becomes 1 over 3. And that's it. And there's your expected value. Any questions? So is it safe to say expected value, we're good? We should be able to get full marks. I think there's one in the exam that I just sent you. You guys should be able to do it. There shouldn't be any problems there. Variance. Variance and standard deviation, which are two measures of spread, will be explored in this section. Variance is easier to define and calculate. Standard deviation, however, is just going to be the square root of the variance. Okay, so standard deviation is, we can't find it. The only way we find standard deviation is we just square root variance. So how do we find standard deviation? You square root variance. There is no formula for standard deviation, right? Well, there is, but anyway, you don't need to. You've got variance. Square root of variance. Okay. So there are two ways of finding variance. Variance is represented firstly by var and then capital X and then sigma squared. So sigma squared. And it is the sum of your x's minus your averages, your mean, x minus your mean, squared, multiplied by the probability. X minus mean squared times by probability. Now, I'm not really going to use this one. I use a different formula. So I'm not going to tell you guys to do this one. It's just a bit longer for no reason. I'll obviously send you this booklet so you can have it. I use this one more. So variance of x is the expected value of x squared minus mu squared. So variance of x, this has to be memorized. It's not in your formula sheets. Variance of x is equal to e x squared minus mu squared. Okay. Ex squared. This means, so let's recap something. Recall that e of x meant find the sum of your x's multiplied by your probabilities. Right? That's what the expected value of x was. The sum of x's multiplied by the probabilities. So then ex squared is actually the sum of x squared multiplied by the probabilities. So it's not that much harder. And then once you work out that sum, you're going to subtract it by your mean squared. All right, let's have a look at one. Oh, there's none there. That's okay. We'll make up one. One, two, three, 4, 5. We'll just make it 1 out of 1/4. We'll make this one, that's 0.25. We'll make this 1/4. We'll make this a third. Make this, what do we got? We've got 0. I've got to make sure I don't go over. Plus a quarter, plus a third, plus, sorry. Nope. Not too big. Yes, 1/8, and the last one should be 1/24. Yes, perfect. Okay, so there you go. We'll just make up something. All right, let's find the mean and let's find the variance. So the mean was E of x, or mu, and that was just the sum of your scores multiplied by the probability. So 1 times a quarter, plus 2 times a quarter, plus 3 times a third, plus 4 times an eighth, plus 5 times 1 on 24. So 1/4 plus a half plus 1 plus a half plus 5 on 24. 59 on 24. 59 on 24. In other words, 2.4583 repeater. That should be easy. Variance. Variance, the formula is E of x squared minus mu squared. E of x squared, like I said, if you understand E of x, right, which is the sum of x's multiplied by probabilities, then E of x squared is 1 squared times probabilities, plus 2 squared times probability, plus 3 squared times probability, plus 4 squared times probability, plus 5 squared times probability, minus mu squared, minus 59 on 24 squared. That's it, which I'll work out while you guys see if you've got any questions. $175 on 24. Nope, sorry, that's 175 minus 24, minus 59, I didn't do that bit, 59 squared on 24 squared, minus 59 on 24 squared, 719 on 576, which is 1.24, 1.25, rounded. Okay, any questions? No, I don't really think so. Standard deviation, while we're here, standard deviation is just the square root. So standard deviation is sigma, which is the square root of sigma squared, which means it's the square root of variance. So square root of 719,576. So the standard deviation is 1.12. All right. Any questions? No, still good. For each random, calculate. All right, let's go. I guess I'm just going to wait for you guys now. I'll pause the recording. You don't need to do it 2 ways.